B2, what type of problem is B2? What type of problem would you say is B2? Come on, don't be shy. What type of problem is B2?
Gravitational. Yes.
It's fields and also circular motion. So it's half mechanics, half fields. So let's do the A part. You know, it's actually, it's quite nice. So for the A part here, what you have is, you have the bucket, and the bucket is being spun around. So I'll draw it in its 4 different positions, for example. So you have one here. So, do you get what I'm, oh my goodness. The bucket is being spun around. Now the radius is 0.654 meters. The frequency is 1.25 hertz. And the mass is 1.45 kilograms. Yeah. So he likes this question, I think, because he's asked this exact same question twice in the last 3 years with the bucket being spun around. So at its highest position, there are 2 forces acting on the bucket. What are they?
Weight.
The weight and the tension from the string. Do you understand? That there's 2 forces here pulling it down. The string and the earth. Now, this force here is actually a circular force. So what's the formula for the force, the circular motion force? It's m omega squared or. So he wants the t, so the t would be m omega squared or minus w. Now, do we know the m? We do. Do we know the omega? We can get it from using this f here, because what does t equal? 1 over f. And what does omega equal? 2 pi over t. But t is 1 over f, so omega is actually just 2 pi f, if you want. So, we know the m, we know the omega, we know the or, and what's the formula for weight? mg, do we know the m? We do, so just type in the numbers in. 1.45 times 2 times pi times f minus m times g. I forgot the square on my 2 pi f. Right, so here I get tension at the top, so T top equals 75, is it 75.2 newtons, Fahad?
This is the answer?
For A part 1?
No.
What is it then?
Do you want to tell you?
Yeah.
44.3.
That sounds... What's his answer for A part 2?
72.7.
Yeah.
72.7. You want to see?
No, I know, I must have typed in something wrong, maybe my radius.
The formula is right.
Oh wait, hang on.
Yes, the radius is...
I mistyped my radius, this is the problem.
What did you write?
44.27?
Yeah.
Great.
Did you change it to anything?
Did I what?
Did you change the radius to anything?
What do you mean?
Like maybe...
No, I just mistyped it, that's all. Okay, A part 1. Now part 2 is extremely similar. They want the force at the bottom. So at the bottom, how many forces are acting? 2. two, what are they?
Tension
The tension,
and
the weight. So the only difference is the weight is now acting down. Do you understand? Whereas here they both act towards the centre. Here this acts towards the centre, but this acts away from the centre. So it's exactly the same, except instead of W, it's minus W. So instead of minus here, it's plus. So I barely have to change anything except the plus on the calculator. And for this part, I get T bottom equals 72.72. That should say newtons. What am I doing? Meters. Newtons. Okay. Next, he wants the velocity. What's the formula for velocity? Omega or.
oh yeah.
And omega is just 2 pi f or. So 2 pi f or. Fahad, is the answer 5.136?
No,
No? What is it?
2.53.
2 pi f. Sorry. Omega 2 pi f or 2 pi. Well, they want the minimum. I misread the question. So, in fact, the part 3 doesn't. Listen. The part 3 actually really should be more like a part B. Do you understand what I mean? That the part A3 is quite different to part A1 and part A2. In part 3, the speed now changes. It's not the same frequency. Okay? So, in fact, that's quite different enough that I need to redraw it. So what he's saying in part 3 is that the bucket just about travels in a circle. So what that means for the diagram is when the bucket is at the very top, it just about stays at the very top. In other words, that imagine that you were turning the bucket really, really slowly. So can you visualize that? It's spinning really slowly. So what happens when it makes it to the top if it's going too slow? It'll fall straight down, won't it? Can you picture you're spinning it around, but if you start to slow down, if you go slow enough, it will fall straight down. So if you look at the top here, or maybe if you look at the top, you want, it's just the V. It's not anything special, it's the velocity it's travelling at, that's all. Yeah? Yeah? Okay. Yeah, so what I was saying is, on the top, you don't want the tension in the rope to be a little bit more than 0, at least. Because if you imagine that if the tension here in the rope was 0, then the rope would be loose. You want it to be tight at the top.
That's why I want it to be
You want the speed more than the weight.
But speed and weight is speed and force, so you can't really compare the two. Do you get what I'm saying?
But you can make any relation or equation something like that.
But what I'm saying is that you want the tension in the rope to always be positive. That the moment that the tension equals 0, it means the rope has gone slack. Do you know this word, slack?
But
No, firstly, do you know this word slack? I don't know this word slack.
When you slack your shirt, the elastic becomes.
Slack is when it loses its tension. So it's kind of loose then. You don't want your string to be loose. You want it to stay tight. So you want the tension to always be at least a little bit more than 0. The moment it is 0, it means the rope is slack and the bucket could fall. Yep.
it should be more than like way more than 0?
No. Any amount above 0 will do.
Okay.
Yeah. Okay, so, do we have the force here at the top or at the bottom, wherever? But really we care about the top because this is when it could fall down. You want, F is the circular force, which is m omega squared or. F is weight plus tension equals m omega squared or. At the worst case, the case you don't want, what happens to the tension? It's 0. So if I just write here, worst case, the weight will equal m omega squared or, and the omega will be w over m or square root. So you want your omega to be greater than this. Okay, now actually what's the formula for w? mg. So the m's actually cancel, it's just g over or. What's the or? 0.654. So here I get the omega must be greater than root 15. So the velocity, which equals omega or, the velocity must be greater than root 15 times or. So I have my answer that the velocity must be greater than 2.533 meters per second. But I really strongly feel that this question should almost be called part B because it's quite different to the previous two parts. But anyways, that's life. Now, is that right now, Fahad? Yes. Now, I don't like it because not only do I feel like it's different enough to be a different part, all this effort got me how many marks?
2.
Only 2. However, the next part is quite nice for 2 marks. They want the time. So that's just 2 pi over omega.
No, but you know they said determine the minimum condition
Yeah.
required to keep the water in the bucket. So that means
Essentially the same thing. That's
Time
it.
this fella.
it's meant to be equals to, it's not meant to be greater than.
Oh yeah, so I suppose here I should really make it equal and call this V min then. Yeah. But don't worry, if you wrote it like this in the exam, I'd give you the marks because it's clear to me what you're saying. Right, 2 pi over omega. Is the next answer 1.62? Now, please look at this. This is, I find this very odd, that all of this work here gets you 2 marks, and then this work here also gets you 2 marks.
That's weird.
It is quite strange to me.
That's why if you don't understand this concept.
Yeah.
Now B part.
B part, yeah. Okay, can I go down?
You use this formula, right?
2 pi over omega.
Mm.
Yeah. Why? That's what he used, wasn't it?
Yeah,
Yeah.
no, I'm not looking at that.
Yeah.
That's fine.
Continue?
Yeah.
Okay, B part. Right. I won't write it down because I'm too tired to write a sentence. What's geostationary orbit?
The orbit,
I'll write it down. It's when the time, or when the periodic time for a satellite in orbit of a body equals the time of 1 day for the body. So basically, for Earth, the geostationary orbit is when the periodic time for a satellite, or I should say, a satellite is in geostationary orbit if its periodic time is 24 hours, because that's the time for one day on Earth. Right, part 2 now. Determine the height above the surface of the Earth of a geostationary satellite, and they give us the mass and the radius of the Earth. So what we have here is we have a satellite travelling around the Earth, and we have a mass here. So we know that the force from the Earth, from Newton, is gmm over r squared, where m is for the Earth and small m is for the satellite. But what type of motion is this? Circular, isn't it?
Mm-hmm.
So you can say F equals m omega squared r. We can make these equal and get gmm over r squared equals m omega squared r. So the small m's cancel. I can bring the r squared up to the right to make r cubed. I forgot what I was looking for. Oh yeah, I'm looking for the r cubed. I can bring the omega squared down to the left. And then, I know it's getting messy, and then cube root. So cube root gm over omega squared. Do we know the omega?
Yes.
Well, kind of, yeah, because we know the t.
Yeah.
So we know that omega is 2 pi over t. So if I just put in the numbers, I can get it. G is 6.7 times 10 to the minus 11. And 24 hours times 3,600 seconds in an hour. Oh, and I need to know the mass of the Earth. What's the mass of the Earth? 5.974 times 10 power 24. Right. In kilometers, it's huge. 42,236 kilometers. Yay or nay?
It's in meters over here, but it's 3.59 times 10 7
No,
meters.
I know my problem. They asked for the height, I believe, not the radius. Hmm?
The radius.
The height of
Yeah.
the surface of the
We have to take away the radius of the Earth to get the height, because what I got was the total. So the height is minus then 6371, and I get 35865 kilometers.
minus the radius of what?
Yeah.
Okay.
The moon orbits the Earth every 27.3 days. What's the radius of the orbit around the Earth? Okay, so what we have now is, here is the Earth, here is the moon, and they want the radius. So in fact they want the radius? And so in fact I can use the same formula as earlier. Guys, look, I can use this same formula here. So the radius would be, the only thing I have to change is the time, which is 27.3 days. That's all I have to change, is it?
Mm-hmm.
What did you use for the time before?
24 hours.
Why do you use the forms?
Because it's in geostationary orbit. Is the answer in kilometers?
Yes, answer in meters. meters,
Okay.
One answer.
Is it like 38? Yeah, so the radius is 382,938 kilometers. And the very last part is what is the density? So density is mass over volume. Now they give, and the volume is 4 over 3 pi r cubed. Now we know the radius of the moon, but what we don't know is the mass of the moon.
But
We can find it because they give us the g for the moon. They say the g for the moon is 1.622. And you have to remember the formula for gravitational field strength? It's, what is it? I can't think about it right now. It's something over r squared, isn't it? GM over r squared, isn't it? Let me just double check. It is GM over r squared, yeah. So we know what the m is. The m is g r squared over g. So if I pop that back in here to my formula, I get g r squared over g over 4 over 3 pi r cubed. Now I can do a lot of simplifying here. What can I cancel? The r squareds here. So this would equal 3g, hang on, let me put the 3 up here, and then I can bring the 4 pi r up here. Yeah, so this can be 3g over 4 pi g r. Fantastic. Now the g here is 1.622, and the big G is 6.67 times 10 to the minus 11, and the radius is given as 1.737 times 10 to the 6. So the density is 3,342 kilograms per meter cubed. Number 3 is very nice. Let's have a look at number 3. We'll get 3 and 4 done, I think. Okay. Have a look at 3. I'm closing this now.